Hello everyone, how are you? Did you ever hear about the Nernst equation? Or do you want to learn about it? What's the meaning of Nernst equation? The Nernst equation is an equation that is used to determine the cell potential under non-standard conditions. It relates the measured cell potential to the reaction quotient and accurately determines equilibrium constants, including solubility constants. Now let's move to the Nernst equation applications. The Nernst equation can be used to calculate the single electrode reduction, and the second is oxidation potential at any conditions, and the third is standard electrode potentials. The fourth is EMF of an electrochemical cell, EMF which meaning the E cell itself, and the last is unknown ionic concentrations. Nernst equation of EMF. E cell equal E standard minus RT over NF times ln Q, where R is gas constant, which equal 8.314 joule per mole a Kelvin. The T is temperature in Kelvin, and the N is stoichiometric number of electrons in the reaction. And the last is F, is Fourier constant, which equal 96.485 coulomb per mole. Next, we look at an example. Calculate the cell potential at 25 degrees Celsius for the voltaic cell shown below. This voltaic cell is composed of a zinc curved cell and a copper half cell, and the concentration of the zinc half cell is 2.15 mole, and the concentration of the copper half cell is 0.215 mole. We will start by calculating the reaction quotient. When calculating a Q, the concentration of the half cell that undergoes oxidation, that's the anode, goes on the top. And the concentration of the half cell that undergoes reduction, that's the cathode, goes on the bottom. This gives us a value of a Q of 10. Next, we will calculate the standard cell potential. The reduction potential of the copper half cell is positive 0.34 volts, and the reduction potential of the zinc half cell is negative 0.76 volts. This gives us the standard cell's potential of positive 1.10 volts. And finally, we will input the value into the Nernst equation, and we do the calculation. We get a cell potential of positive 1.07. Classification of electrode. The electrodes can be classified into two categories. The first based on the types, and the second is based on the function. And we have two classifications of the second, the reference and the indicator. Today we will talk just about the reference. The first type consists of a metal strip immersed in solution of its salt, and you can see the notation and electrode potential. The second type consists of a metal strip covered with a hardly soluble compound of this metal and immersed into a solution of the same anion. You can see the notation and the electrode potential. And the third type is the redox electrode. Consists of an inert metal immersed in the electrolyte of oxidized and reduced forms of an element. You can notice the notation. It has three elements: the oxidation of the Fa positive 2 and the platinum. And you can see the electrode potential. What is the reference electrode? The electrode potential of any other electrode that can be measured is called a reference electrode. Why do we need reference electrode in your opinion? A reference electrode is needed to find the electrode potential of any other electrode, as the potential of the reference electrode is known. The first type of the reference electrode is SCE, which meaning saturated calomel electrode. The SCE is a half cell composed of a mercurous chloride, Hg2Cl2, and calomel, in contact with a mercury pool. The half reaction is described by Hg2Cl2 in the solid phase plus 2A minus to give 2Hg in the liquid phase plus 2Cl minus. And look at the picture. It is the saturated calomel electrode. The second type of the reference electrode is silver in silver chloride, Ag in AgCl. A silver chloride electrode is made up of a silver wire coated with a solid silver chloride deposit. AgCl, scarcely soluble in water, immersed in a KCl solution. The half fraction is described by AgCl in the solid phase plus A minus to give Ag in the solid phase plus Cl minus. And you have the picture. You can see Ag in the AgCl electrode. Thank you for watching and listening.